Okay, good morning or good evening, whenever, depends on what time of day you're watching this. Today we're going to be talking about the parts of an atom. Okay, so let's get the slideshow started. Okay, and we'll get our pen out. Okay, the parts of an atom. What are the parts of an atom? Okay, we've talked about what matter is, and what makes up matter are atoms. Atoms form molecules and compounds, and all the things that we can touch and feel and see, for the most part. I shouldn't say see necessarily, but all the physical things, anything that has mass and takes up space, which means it has volume, anything that has mass and volume is made of matter. So if it's made of matter, which is made up of atoms, what are the atoms made up of? Okay, so the atoms have parts, the parts of the atom. Okay, there are about 115 different types of atoms that we know to exist. Okay, the general structure of them all is generally the same. Okay, so you basically have in an atom, you have a nucleus, which has two types of particles in it: protons and neutrons. Okay. Sorry, E-U-T-R-O-N-S. And then you have what we call the electron cloud or orbitals, which is where the electrons are flying around the outside of the nucleus. Okay, so you have the electron cloud, where you have electrons. Okay. We separate, like I just said, we separate the atom into two areas: the nucleus, which has the protons and neutrons, and the electron shells or orbitals, where we have the electrons. Right? We just said that. I'm just gonna write that down real quick again. Okay. And here's your general diagram of an atom. Okay, and this atom has 3 protons. So based on that, I can tell you that it's lithium. We identify atoms by the number of protons that they have in the nucleus. So each different type of those 115 different types of atoms, each one of those atoms has a different number of protons in the nucleus. And that's how we know it's a different atom. That's what separates one type of atom from another. All right, which basically means one element from another element is determined by the number of protons in the atoms that make up that element. And here's another real general diagram of the atom. And this would obviously be a hydrogen atom because it only has 1 proton. Okay, here you have 1, 2, 3 protons in the other one. Okay? The parts of the atom. Like we said, in the nucleus, we have protons. Now, protons have a positive charge, so they are electrically positive. So they're the part that also identifies the atom and the element. Neutrons have no charge. Okay, so the nucleus overall, so the center of that atom, the nucleus, which is the center of the atom, has an overall positive charge. Okay, so if they said what is the overall charge of the nucleus, you'd say positive, because protons have a positive charge and neutrons don't have any charge, so it doesn't affect the electrical charge of the nucleus. Now when you talk about outside the nucleus, the electron clouds, or the orbitals, you have electrons, and they are negatively charged. So outside the nucleus, spinning around really fast and flying all over the place, you have electrons, and they have a negative charge. So the electron clouds outside the nucleus has an overall negative charge. Okay? All right, now, here's the atomic structure of 3 different types of atoms. Well, you might say, well, how do you know they're different types of atoms? Well, because they have different numbers of protons. Okay? This first one has 1, 2 protons. Okay. This second atom has 1, 2, 3 protons. And this third atom has 1, 2, 3, 4 protons. Now, if I wanted to find out what type of atom each one is called, I would simply go to the periodic table. I would look up and see which atom has an atomic number of 2, and that would be helium. The atomic number is the number of protons. So helium, this is an atom of helium, which has the chemical symbol of He. Okay? And then I would check and say, oh, what's this? It has 3 protons. Where's the atomic number 3? Well, that's lithium. And its a chemical symbol is Li. And then we have 1, 2, 3, 4 protons. And I would say, looking at the periodic table, I'd say, oh, atomic number 4, that is beryllium. Okay? And it has a chemical symbol of Be. What you'll find is all these elements have chemical symbols of anywhere from 1 to 3 letters, mostly 1 or 2 letters. Okay? But we'll get into how to read the periodic table in another video. Okay? Subatomic particles in the nucleus. Well, what do we know about them? We know there's protons and neutrons. So if you were asked to draw a general diagram, okay, of an element, you might say, okay. All right, so if this was the nucleus of an atom that you were drawing, you would have the protons, which have the positive charge, the neutrons, which have no charge, symbolized by that O. Okay, and you would understand that this nucleus, all right, has an overall positive charge. This is the nucleus, and has an overall positive charge. Now, these protons and neutrons, they have mass, and they take up space. That's what gives matter its mass and volume. Okay, so protons and neutrons have mass and volume. So they take up space, and they will occupy a certain area depending on their size. Okay, so different atoms have different numbers of protons and neutrons, so different types of atoms take up different amounts of space and have different masses. Okay, what do we know about protons? Well, we know they're positively charged. We know they're located in the nucleus. Okay, one of the things you might have heard me mention earlier is the number of protons gives us the atomic number of an atom. So all you have to do to find out the atomic number is count the number of protons. Okay? So remember that. That's key. The number of protons gives us an atom's atomic number. Okay? Oh, for some reason it froze up there. Now, each different type of atom has a different number of protons. So each different type of atom has a different atomic number. And that number of protons identifies the element. Okay? So like I said here, we have 1, 2 protons. 1, 2, 3 protons. 1, 2, 3, 4 protons. So you have 4 different types of atoms. The atomic number of this first one is 2. The atomic number of this second atom is 3. The atomic number, I'll write that down so you know what it is. The atomic number of this fourth atom is 4. Okay, if we had another atom drawn up here and it had 5 protons, okay, and 5 neutrons in the nucleus, you know the atomic number will be 5, and you'd have 5 electrons flying around the outside here. Okay, and we'll just do a real quick sketch. Okay, so atomic number, what is it? It's the number of protons in an atom. count the number of protons, and you have the atomic number. Okay? So count the number of protons up, you know the atomic number. It's getting repetitive here, but that's something you need to remember. Now the neutrons, what do? Well, they occupy space and have mass, so they add something to the overall mass of an atom, okay? But they have no charge. They don't affect the electrical charge of the nucleus, but they are located in the nucleus, okay? Now this is important because we'll get to this in the next video. Atoms of the same element may have different numbers of neutrons. So what we're saying there is you might have, for instance, that lithium atom, okay? This lithium atom over here might have 1, 2, 3 protons and 1, 2, 3 neutrons. But there are lithium atoms that exist that have a 4th neutron. Now that doesn't affect the overall charge of anything, but it does affect the mass of the atom. So as when we get to this in a couple seconds, the atomic mass is going to be the protons plus the neutrons. So there are some atoms of lithium that have 4 neutrons and some atoms of lithium that have 3 neutrons. But all of the atoms of lithium always have 3 protons. So that's how we know it's lithium. We count the protons. We say 1, 2, 3 protons. Oh, it's lithium. Oh, but it has an extra neutron. Not a big deal. We call that an isotope of lithium because it has a different number of neutrons. Okay? Now, so there we go. Atomic mass is equal to the number of protons and neutrons. Okay? So, atoms of the same element always have the same number of protons. Now, in order to calculate the atomic mass, we count the protons and we count the neutrons and we add them together. So the atomic mass of an atom is equal to the number of protons plus neutrons. Okay? So let me go back one. So if we went back to this page, all right, this atomic mass of the helium atom here is 1, 2 protons plus 1, 2 neutrons. Okay, we add them up. The atomic mass is 4. Each one of these, each proton has a mass of 1 atomic mass unit, 1 AMU. So we call this atomic mass of a helium atom is 4 AMU, 4 atomic mass units, because protons and neutrons each have a mass of 1 AMU. So if this was a lithium atom, over here we have 3 protons. I'm just going to put a P next to it. 3 neutrons. So it has an atomic mass of 6 atomic mass units, 6 AMU. Okay? And over here we have beryllium. We have 1, 2, 3, 4 protons and 1, 2, 3, 4 neutrons. Okay? So this beryllium atom has an atomic mass of, 8 atomic mass units, 8 AMU. In the case of an isotope, like we mentioned before, sometimes they have an extra neutron. So if we're doing the lithium here, and this lithium atom had a 4th neutron, you would have 3 protons plus 4 neutrons. Okay, so in the isotope of lithium, we call it lithium-7 because it has an atomic mass of 7 AMU. Okay, but we'll get into that when we talk about isotopes and ions in the next unit. Okay, so atomic mass, we just talked about this. Subatomic particles outside. Now, we talked about the nucleus and we talked about the protons and the neutrons. Now, we have electrons, and they're negatively charged particles. and they're very small, and they're in constant motion around the nucleus. So they're spinning around that center. So very, very fastly. Very quickly, excuse me. All right, so in a neutral atom, there are equal numbers of protons and electrons. Okay? Atoms bond to other atoms to fill their outermost shell with electrons. So the need for electrons is what causes atoms to interact with one another chemically. Sometimes they trade or take, I should say, electrons from other atoms. Sometimes they lose electrons to other atoms, and that's when we call that's when ions are formed. Okay. Sometimes they share atoms with other atoms. That's what we call a covalent bond, where they're sharing the atoms. The atoms are shared between and go through both orbits of both atoms. Okay. They are located in what we call electron shells, also known as the electron cloud or orbitals or energy levels. Okay? The outermost electron shell of each element wants to be full. And once it's full, it becomes more stable. Okay? So atoms are always out there trying to fill their outermost shell until they're full. Okay? How do we calculate the overall charge of an atom? Well, it's pretty simple. You count up the number of protons in the nucleus, and that's the number of positive charges you have. And then you add the number of electrons up in the electron cloud, and that's the amount of negative charges they have. If there's an imbalance, it's a charged particle, meaning it's either going to have a positive charge or a negative charge. So when an atom gains extra electrons or loses electrons from the outer shell, they affect the electrical charge of that atom. Okay? So what we're basically saying here is these electrons are spinning around around the outside of this. And sometimes if the shell isn't full, they may gain an extra electron. Or a lot of times what happens, like lithium is a very reactive element. So lithium will many times lose an electron, which will mean it only has 2 electrons in its outermost shell. Okay? When it loses an electron, you would then have one less negative charge. So if we looked at the overall charge of this helium atom, we would find that you have 1 positive, 2 positives in the nucleus. And the electrons, remember, are negative, so you have 1 negative, 2 negatives in the outermost shell. So you have 2 positives and 2 negatives. The overall charge is neutral. There is no overall charge. It's 0. Okay? Here, same thing. You have 1, 2, 3 positives in the nucleus, and 1, 2, 3 negatives in the electron cloud. So its overall charge in this particular state is 0. Its net charge is 0. If it loses an electron, so if this electron gets taken and goes to another element, or another atom, I should say, you then have 3 protons in the nucleus, and you'd end up with only 2 electrons. So you'd have an imbalanced electrical charge, because you'd have 3 positives and 2 negatives. So if it loses this electron, the overall net charge is going to be plus 1, because you have 3 positives and 2 negatives. Okay? And that's what we call an ion. So when you lose electrons, the atom becomes more positive. Now, if that's losing an electron, some other atom is gaining electrons. Okay, so that other atom is going to become more negative. All right, so if you have more electrons than protons, you have an overall negative charge. Okay, so to recap today, all right, we had the parts of the atom. In the nucleus, we had protons and neutrons, and we said the nucleus has an overall positive charge, electrical charge. The orbitals, or the electron shells, okay, is where the electrons are housed, or they're flying around. Okay, and it has an overall negative charge. The atomic number, which is equal to the number of protons in an atom. The atomic mass number, which is equal to the number of protons plus the number of electrons. Oh, sorry, that's a mistake. Plus the number of neutrons, excuse me. I'm thinking, oops. Plus the number of neutrons. So it's protons plus neutrons. Okay, I'm thinking back, the one more thing I wanted to talk about. When we talk about electron shells, all right, you have the nucleus, and the first shell, the first orbital, can hold 2 electrons, and we call that the K shell. It's symbolized by the letter K. The second shell can hold up to 8 electrons. It's the L shell. It can hold up to 8 electrons. So if it has less than 8, it either wants to gain electrons, lose electrons, or share electrons, so that 8 electrons eventually will fly around that outer shell. All right, oops. And then we have the M shell, and that can hold 8. That holds 8 electrons as well. So you have 1, 2, 3, 4, 5, 6, 7, 8. So we're going to stop there with the third shell for now. Know that on the periodic table there are atoms that have 7 shells, okay, and hundreds of electrons. So as we get bigger and bigger atoms, and those atoms have more and more protons, they have more and more electrons. Okay, I think that should do it for now. Be prepared to have a do now or a quiz on these notes. So you should make sure you take notes on this and watch it again if you can. All right, take care. We'll see you tomorrow.